All right. So here's our stool. Everybody has this designed. We have all of our dog bones at the corners. They're all in the right places. We're good to go. This is ready for manufacturing. We're going to be CNCing this. And the way we designed it was with that manufacturing in mind. We call that DFM, designed for manufacturing. So all of our parts are exactly the thickness of the plywood we're going to be using. And all of these parts have been set up so that we can literally use our CNC router to cut it out from one direction. We don't have any two-sided machining that we need, but what we do need is to be able to lay all these parts flat on top of the CNC. So as they are right now, you know, the seat we could start cutting out straight from above, but we don't have a machine that could cut the legs from the side. So we need to do a whole setup, okay? And it's actually called the setup. You'll see it in a second. And we're gonna do that in the manufacturing space. So instead of design, we're gonna go into manufacturing. It's gonna look, the stool hasn't changed. It's the exact same model that we had before, but all of our tools at the top of the screen have gone away. So now we have these new, let me try and get this out of our way so you guys can see. Can I move this? There we go. So we have all these new tools along the top, all specifically to how we're gonna cut these parts out and how we're gonna make them. All of the tools on the screen right now are for milling. Milling means that your cutting bit is spinning and either your cutting bit is moving past your material, your stock, and cutting it away, or there are milling machines that cutting bit spins in one fixed place and you move your material past it. So you're either moving the cutting bit or moving the material, okay? There are other options here. Turning is something else. Turning is when you spin your part and the tool sits still. So it's almost exactly the opposite of milling, okay? Turning, you might have heard of a thing called a lathe, right? A lathe spins our parts and we cut them. This is usually for circular parts, right? And so we're not gonna be doing any turning. Additive, you know what that is. Additive is like our 3D printers. Instead of taking a whole block of material and cutting away to reveal what our part is, we start with nothing and we add on and add on and add on to build up to our part, okay? And then there's a whole bunch of other ones that I'm actually not super familiar with. But like I said, Fusion 360 has tons and tons of features beyond what we're gonna use it for. So we're gonna go into the milling. This is where we're gonna live for our CNC fabrication. And what we need to do first is rearrange this stuff so that they're all laying flat and they'd be able to be arranged on top of our CNC machine next to one another. Depending on what models you're making, you don't have to, you can cut out each individual part one at a time, is what we're gonna do with the stool, because our CNC bed is only 2 feet by 3 feet. But some of you have made smaller creative designs, like Andrew did an iPhone stand, and all of his parts would actually fit right on top of the bed in there, and we'd be able to set up one giant process to cut out all the parts all in one step. But we're gonna do this one by one. So let's start laying this out first. To do that, we need to create what's called the manufacturing model, okay? So under setup, we're gonna create manufacturing model. You get this new item on the navigation bar here. Let me close this side piece so you don't need that. Get a little more room, okay? And now inside of here, manufacturing model, we still have all of our stuff from our sketch, okay? And inside the manufacturing model, we need to edit this manufacturing model. So we don't just want those parts sitting where they were, we want to edit them and move them around. So we're going to edit manufacturing model. And now notice everything has just changed in the top toolbar. We're still in our manufacturing space, but now we're in our familiar design tools. And the first thing we're going to do is create a sketch. that defines where we want to lay these things out, okay? And I want to put it on the XY plane. You have to make sure you click the XY plane. Some people didn't design their stool with Z being where the seat is, like the stool is kind of laying on its side. Make sure, even if you've done that, you click on the XY plane for this step, for our sketch that we're doing, because that is the cutting surface of our CNC machine. It actually has its own coordinate system built in, and the XY is, well, X is left, right, Y is forward, back, and Z is, you know, towards the bed and away from the bed, okay? So we're gonna click on that, and right now I can't actually click on it. Every time I try and click on the XY plane, the seat is selected. So let me hide the body, and now I can actually click on the XY plane, and I'm gonna define the area that I want to arrange these. Now, for simplicity right now, I'm gonna do an area of 4 feet, so 48 inches by 8 feet, 96, okay? And that's the size of a sheet of plywood. Our machine can't fit an entire piece of plywood. It's only 2 feet by 3 feet, but there are machines that are this big, but I'm doing a large space so you can see how multiple parts can be arranged next to each other. All right. And so that's it. That's all I need. And I can finish that sketch. And I actually don't even need to extrude this to show the thickness of the plywood. I can just leave it as a flat sketch. And if I bring my bodies back in, now all I want to do is put each part laying flat on this sketch. And to do that, we go into Modify and click Arrange. We got this set of options. And I will first select the plane of that work area that I'm going to deal with. So there it is. One selected.
Mr. Varney, where's Modify?
On the top toolbar, you see these. Underneath it, it says Modify. This is where you have a whole bunch of additional features. So Modify and then Arrange.
Oh, okay. Thank you.
Now, we want to choose what objects we're going to lay out here. So let's start with the seat. There it is. And then it moved it. And now I want to pick one of the legs also. Wait a second. Why did the seat move? It's all attached because when we originally did these designs, we kind of defined the seat itself by a vertical sketch of the legs, and then we put another sketch perpendicular to that. And so they're all intertwined right now, and it's because they're still bodies. So let's cancel this. We don't actually want to do this yet. We're going to go, I hit cancel, it puts it back. And I'm going to go to my bodies. I have 3 bodies in here. You can tell they're bodies because they're first in the bodies folder, but also there's this little cylinder next to them. And if I just right click on that bodies folder, I can say create components. And now notice the bodies folder is gone, and they're still called bodies because that's the name. You know, I never renamed them, but they have this cube instead of a cylinder. And that means these are components now. They're finished, quote unquote, finished parts. Okay. They can be moved independent of one another. All that sketch information is back on our design page where we have the body still intact, but now these are components. And if we go through Modify, Arrange again, and we select this plane, and now we can select multiple components. So I'm going to click the seat. It will put the seat inside, and notice the legs don't go with it. I can click on one of the legs. It's going to place both of those there, and I'll click the last leg. It arranges all 3 of these things together. They're all relatively spaced out nicely and, you know, put into the corner because we're going to try and conserve material and things like that. And so one last thing we can check is our border spacing. So that's how far away are they going to be from the edge of that sheet of plywood and how much space is between them. I have a 1/2 inch between them because I know I'm going to be using a 1/4 inch cutting bit. And I think about double that size. This way, as you're cutting around one, you don't cut into the other. So that's it. We're ready to go. These are now laid out flat. But if I go back to my design space, my stool is still fully assembled. Nothing changed. And I can always go back and edit things and change them over here. So let's go back to manufacture. We're all laid out. We're pretty much ready to start with our CNC process. Now, we talked about tool paths the other day, and that's basically telling the machine which direction to go and how to cut. But we can't do that until we have what's called a setup. A setup is basically your raw material. Where is your raw material located? And what is the size of this raw material? So we need to create a new setup. So if I go to setup and then new setup, it kind of tries to define it on its own to start. So basically it's saying, all right, you need a piece of material that's big enough to fit all three of these in it. Now, we might want to say, all right, let's make this actually the actual size of my 4x8 sheet of plywood. But remember what I told you, our machine can't fit all three of these. We'll have to cut each one individually. So instead of model where it says nothing, it's weird that it says nothing to me. By default, it chooses everything. But I'm going to select something. Instead of nothing, I'm going to select one of these sets of legs. And so now we can see that yellow, it's a rectangular prism, is defining that piece of material that we will be cutting out. And we can go to our next, well, a few things. First, I always move my origin. We have to define where 0, 0 is for our machine and for this setup. I'm always going to put it in the bottom left corner. It doesn't have to be. But we go to this work coordinate system. We go to box point, and I always click that bottom left corner. This way, if I always do that on every sketch, I know when I go to set up my CNC machine, as long as I have enough room to the right and behind my cutting bit, we'll be in good shape, okay? I need to tell it what type of stock I have. I always want to leave a little bit of material on the side. It doesn't have to be a small amount. We could have a bigger amount. I'm probably going to put a large piece of wood on here. But if you put 0 for like how much extra material is on the side, it won't think it needs to cut like things like the bottom of the legs. Because if you say there's no material there, they'll be like, oh, it's just pressed against that side. I don't need to cut it. So you always want a little bit. But I'm actually going to say no top material, no top offset. If there was a top offset, the program might think it needs to cut a layer off the top before it gets to the model that we want to come out of this. So we're basically saying no top offset, that our stock, our raw material is exactly the same thickness as the model itself, okay? And so we're pretty much good. Everything is good to go. This is literally just defining our materials. I'm gonna hit okay. There's something I noticed in some of these offsets. They were all in millimeters. Even though my design space had a default of inches, the manufacturing model is still in millimeters. Let's turn it over to inches because the CNC machine we have uses imperial units. So now everything's inches as I go to start typing things into our menus. Now we have to choose what type of cutting process we want to do. Our machine can do 2D and 3D manufacturing. So 2D is just like cutting out shapes. Think of how you would cut scissors on a piece of paper. That's what 2D is. 3D is carving. So think of like sculptures, right? Like it literally can carve full three-dimensional stuff. Our design, we kind of eliminated the need for that. And you can go down here and there's a whole bunch of 2D operations, okay? The one we need is called 2D contour. It just means cut around my shape. That's all it means. So I'm gonna click 2D contour, and then I need to tell it which shape I wanna cut around. And I'm gonna say cut around the bottom edge of my model. Okay, you could click the top or the bottom, but I'm gonna click the bottom, okay? And now we get this whole set of options here on the side. It's on the second tab right now because we're choosing geometry. I already selected the shape I want, so I'm gonna actually go back to tools. Now we need to tell it, what is our machine? What are we cutting with? And so when I go to tool select, I have some ones that I've chosen recently, but you might need to go into the Fusion 360 library, and where our cutting tools are in inches, and I'm gonna go to tutorial inch, and I'm looking for there's like tons and tons of tools, but I'm looking for milling tools, and I'm looking for flat end mills. So you can use these filters to kind of find things. And they have a few default flat end mills. And we want our 1/4 inch one. So here it is, diameter 0.25, tool number 4 here, and I'm gonna load that. Now, I'm not sure if the first time you do this, you'll have a tool holder. That's what this blue thing is. It's the thing that actually holds that end mill. If you do, we'll find one. We'll get kind of a default one. We actually can measure the tool holder that's actually on the machine and build it exactly the size and shape that it is. The reason you'd want to do that is if you were doing some carving and things. Imagine if you were trying to carve inside of a deep pocket, you wouldn't want the thing holding your tool to run into your part. And so it needs to know, where is the machine so I don't crash. And since we're doing a 2D contour, it's not super important. So I'm just going to choose that 1/4 inch end mill, select it, and actually, if we go over here, we can see it in our picture now. So we're getting closer to finishing this manufacturing. Now, feeds and speeds, I'm going to tell you defaults. We really will, there's like a lot to this, but we can actually look up some defaults. So our machine's a ShopBot. ShopBot on their, in their manual, they have things like soft plywood and, laminate plywood or hardwood. So we can choose some numbers based on parameters that they give us. I'm not getting into it. It gets real deep really quick. So let's skip those for now. We'll just leave them as their defaults. Geometry. So far, this looks great. The only problem is, if you cut out a complete shape and remove it from the external piece of plywood that's actually screwed to the table, what's going to happen? Like, imagine if you cut out a circle. When you get to the end of the circle and you finish cutting it out completely, it's no longer what? Not full. It won't fall through because it's sitting on something. But you're right. It's like released from the plywood, and then it would kind of rattle around. So we need to do what's called tabs. And if I just click that, you can see that there's little rectangles of material that won't get cut. That's basically what it's doing. So it's leaving it attached. There's like way too many of them right now, because remember, if they're not cut, who has to cut them? You'll have to manually cut them. So you'll go in and cut them, and then you have to sand them smooth and all that. So we would change some of these, but let's just leave this to some of the defaults to see what what this is going to look like. These ones? So the tab height we have here is 0.06 of an inch. So it's thin, really thin. That's usually, once you leave those tabs, you can literally, like, by hand break it off. So we got our tabs. This thing won't detach from the plywood and rattle around. We can think about heights. Now, without getting into every detail of every type of height, when I hover over here, it'll tell me what things are. So right now, this is the clearance height, and it's going to tell me clearance height is the first height the tool rapids to. Rapid is like high speed movement. There's like something defined as rapid movement. Okay. And all of these things, retract height, feed height, top height. So top height and bottom height are probably the most important. Our top height is basically the top of our model. Okay. It's the top of our cut. It's when we expect to start cutting. Our bottom height is the deepest our cuts will go. And right now, our bottom height is set to exactly the bottom selected contour, right? We selected the bottom of our model. That's where we're going to cut to. The problem is if you leave it as exactly there, there's a chance that you're just a teeny tiny bit off, like you're exactly there. You might leave a little thin piece of paper thick piece of material there. So actually I want to go below the bottom of my model. I want to go a little bit through it so I know that it's completely cut through. So I'm going to actually make this negative 0.05. And now I know I'm cutting through the bottom of that material. And then we can go to things like passes. So currently, for the what? So let me go back to our heights. For top height, they said stock top. And remember, I already defined the stock top as exactly the height of the model. So, and remember I said there was a little offset and I said make the offset 0. So that yellow box is exactly the same thickness as my model, which means this stock top is the model height. So I've already kind of like locked them exactly on top. So all finished. Now I'm gonna just say done for now. And I've already kind of, sometimes I'll just finish this so I can see it before I even go into any settings. But if I look, they're showing me the material. The green is the material. I can see where it's cut through. And if I angle it, you can see the tabs that are there. So this looks pretty good. And I can actually simulate this. So let's click on it. If I right click, I can get my options and I can say simulate. If I zoom out, I can actually play this and I can slow it down or speed it up. Okay, and it looks good. The only problem I have with this is that I basically am cutting all the way through in one single step. I don't really love that. I'd rather, the diameter of the bit is 0.25. Usually you don't want to cut deeper than the diameter of the bit in a single pass. Now, there are ways around that. You can go deeper and cut slower and change feeds and speeds. But for rule of thumb, diameter of your bit should be like your maximum depth. So I'm going to actually close the simulation. I'm going to go back to this toolpath and I'm edit it. And for passes, I'm going to let this say multiple depths. And now the maximum roughing depth, roughing just means we don't care about the finish. We don't care about like what it looks like. Sometimes you'll do a finishing pass, which means it's going to take off a tiny thin layer and it's going to go nice and slow and make it look beautiful. That's usually more important for things like metal. For plywood, it's not so important. So basically, I'm going to do all of these cuts in roughing passes. Okay, so I allowed it to rough the final, meaning once you go to the very bottom of the hole, you can still be doing all the rough cut settings. And I'm going to say maximum cutting depth instead of 0.04. That's really small. I'm going to say 0.2. Well, it's not the full diameter. Full diameter is 0.25, a little bit less. I think we're safe. Okay, I'm going to hit OK. And now when I zoom in here, you can see there's multiple. Maybe in here you can see it. There's multiple blue lines. Each one of those blue lines is a pass with the tool. So if I simulate this now, click on it, say simulate, and I press play, we get to watch it. I'm going to crank up the speed. This little slider will make it go faster. And now it's passed around already 2 times. And now we're going our 3rd time and cutting all the way through the material. So all the way cut through on its last pass, showing the tabs, everything looks good. So the last thing we need to talk about, I'm happy with that. This is basically ready to go to the machine as long as we know our feeds and speeds are tuned in properly. And then we need to do what's called post-processing, which is generating, post-processing is generating the G code for our specific machine. Because every machine, you know, there's different manufacturers that make different machines. They're expecting the code to have certain different formats. And so we got to make sure that we choose the correct, what's called post-processor. So that's that. I'm going to finish our recording. I'll post this up so you guys can follow along, and then tomorrow we'll finish the last bit of this.